Welcome to another video. This video's learning objective is to recognize and use the equation of a circle with center at the origin and to find the equation of a tangent to a circle at a given point. And this is actually a higher only topic. So let's consider a circle at the center with its center at the origin. So actually, instead of there's a circle to linear for a reason. And I'll move this to so that looks like the center at the origin, right? So we'll say that this is the center O at 0, 0, and this is the circle. And let's suppose it's on a coordinate plane, an xy plane or a Cartesian plane maybe. And let's remember what the equation of a line is, for example. Remember we talked about this before. The equation of a line is the equation which every point on that line satisfies. And by the same logic, the equation of a circle is basically some equation that we can generate that every point on this circle will satisfy. So let's think about some random point on the circle on circumference, which is kind of what the circle itself is only the circumference. The set of points is the circumference, right? So let's just think of a point on the circumference. And this is some general point x, y. We know that there's a certain radius. So let's say that the radius is r. Now, when we draw this here, right? Well, we can also say, if this is an r here, we can say, to get to the point xy, we travel x along the positive xi direction and y up. So, we know that if we do this, it's a bad color, not very visible. So we have this. This is the length y, and this is the length x. And of course, it's going to be a right angle triangle. And now the first thing I see here is just Pythagoras. And from Pythagoras, we know that x squared plus y squared will equal to r squared. And if you think about it, every single point on the circle, no matter what x and y is, this is going to be true for every single point. Why? Well, because the radius is constant. So no matter what point you pick, the x coordinate and the y coordinate will satisfy this equation that x squared plus y squared is equal to r squared. And as such, we've actually found the equation of the circle with the center at the origin. So you'll see it in the form of, say, x squared plus y squared is equal to the radius squared. So if I showed you the equation x squared is equal to 58 minus y squared, and I asked you to tell me what this is, and maybe tell me the radius, well, what you do, you could rearrange to x squared plus y squared is equal to 58. And we know that then the radius squared is equal to 58, so the radius is just root 58. And of course, it's the centers at the origin. That's the only one you have to deal with. Of course, there's equations of circles that aren't at the origin. You could have the circle and move it up here, for example, or up here. But that's outside the scope of GCSE. That's actually an A-level topic. So we just deal with it when it's at the circle. And now this is the intuitive way to arrive at the equation of the circle. Let's talk about the tangent to the circle. Well, actually, no. Before we do this, actually, we'll just do a few quick exercises. So let's say I've drawn the, let's say I draw something. Give me a second, I'll draw it. If I get rid of this stuff. So let's say I draw a circle, which is done here already. In fact, it'd actually just be worthwhile if I draw another one altogether. So let me draw a circle. And I'm just going to do this freehand. The center is at the origin. Okay, that's such an ugly circle, I can't. Sorry. Okay, so we've got the circle, center at the origin. And I can tell you, say, for example, one of the points on the circle is, let's say, 7, 8. Can you tell me what the equation of the circle? So you know the origin is at 0, 0. So there's a few ways to go about this. We know that the equation of the circle in general is x squared plus y squared is equal to radius squared. So we can just plug in a few values here. We can plug in the value we have and find what r squared is. Another way was we can look at the diagram and find r squared directly. So if we just draw this out, we can find r by Pythagoras. And really these are actually the same thing if you think about it. So we know that r squared then is equal to 7 squared plus 8 squared. So the equation of the circle is x squared plus y squared is equal to 7 squared plus 8 squared, which I'll just get my calculator out, is 113. And there we go. This is kind of this is the equation of the circle. Now let's talk about if we're asked to find the equation of a tangent to the circle at a given point, which is the second half of this question. So say we're told what the point is, and we have to find the equation of the tangent. So the tangent, if we remember, will be kind of the line which just touches the circle. So if I actually, better yet, if I get one of these out. So I'd say that just touches the circle, for example. At kind of that point there. So close enough, right? Is a drawing. It just touches there. So now let's find the equation of this circle, this tangent. Well, we know this is a tangent, of course, is a straight line, and it comes in the form of y equals mx plus c, right? So we're looking for the gradient of the tangent. We know once we find the gradient, we know what this point is. So let's say we're told, perhaps it's better to go with this one. If we're told, say, that the point is 7, 8, and we're looking for the tangent at 7, 8. So I just had to clean that up a bit. So suppose you have to find the equation of this tangent that's tangent at the point 7, 8 to the circle with the center at the origin. So, of course, you know that this is equal to y equals mx plus c, and you also know that the radius will kind of start from the origin and actually passes through the point 7, 8, or actually even touches it. And of course, you know these are perpendicular from our circle theorems. So, in fact, actually, we haven't actually covered that they're perpendicular yet. That will be in future video in circle theorems, but I've kind of brought that forward. You need to know that the radius is going to be when it meets a tangent, they're perpendicular to each other. So now that we know that they're perpendicular to each other, we know the gradient of this line, then we can figure out the gradient of this line. So we know that this passes through 0 and 7 and 8. So we say gradient, maybe if we label this as OP, that point's P, gradient of OP is equal to, well, change in y minus change in x, right? So 8 minus 0 over 7 minus 0, which is 8 over 7. Therefore, gradient of tangent, which is perpendicular, is equal to minus 7 over 8, the negative reciprocal, as we talked about before. And so we have that the gradient, so we have that the equation of the tangent is y equals to minus 7 over 8 plus c. It passes through 7, 8. Which is equal to, so it means that the equation of 8 is equal to minus 7 over 8. So there was an x here, times by 7 plus c is true. Rearrange this, so first thing we can do is times everything by 8. So 8 times 8, 64 is equal to minus 7 times 7, minus 49 plus c. So c is equal to 64 plus 49, which is equal to 64 plus 49, which is equal to 113. Oh, yeah, c is equal to 113. So then the equation of the tangent becomes y is equal to minus 7 over 8 plus 113. So that's how we do that, which is kind of, so again, just step by step. First thing we do is find the gradient of kind of the line through O and the point, which is kind of a radius. We know this will be perpendicular to the tangent, so we can find the gradient of the tangent. And now we know the gradient of the tangent and the point it passes through, so we can find the equation of the line. There's a question I have here, which is a bit of a longer question, I feel, more of a compound question. So the graph above shows a circle centered at O. The point P lands on the circle that has coordinates minus 15, 8. The line QR is tangent to the circle passing through the point P. Answer the following question. Calculate the distance OP. So if we zoom in, perhaps, I like to label the coordinates, so I'll just label this minus 15, 8. So it passes through the origin and to P. And we just use a bit of cheeky Pythagoras. We have that this is not minus 15, just 15, and that's 8. So the length OP by Pythagoras, we have OP squared is equal to 15 squared plus 18. Oh, not 18, just 8 squared plus 8 squared. So OP is equal to root of that. So we go 15 squared plus 8 squared. Square root that to get 17. Write down the equation of the circle. This is fairly straightforward. And remember, x squared plus y squared is equal to r squared, not r squared, which is 17 squared. So you might say equation of circle. So x squared plus y squared, therefore is 17 squared. You can leave it in this form, to say 17 squared, because that way you remember what the radius is. Before, so you could expand it out. Hence, calculate the equation of the tangent line QR. Okay, well, first thing we find the gradient of OP, so we'll do gradient of OP is equal to then change in y over change in x. So, in fact, better yet, it's worthwhile writing the 2 points out, especially because we have a minus sign to deal with. So gradient is equal to change in y, so 8 minus 0 divided by change in x, 15 minus 15 minus 0, which is equal to 8 minus 8 over 15 then. So now we have gradient tangent is equal to then. So it's worthwhile actually writing a line saying tangent and radius are perpendicular here. Is equal to 15 over 8. And now we have, so y is equal to 15 over 8 plus c, so equation of tangent. Passes through minus 15, 8, right? So plug these numbers in. 8 is equal to 15 over 8 minus 15 over 8 times 15 plus c times everything by 8. Oh, silly me, I just realized I made such a big mistake here. I didn't times the c by 8, so this was 8c. So 8c is equal to that, so it's 113 by 8. So times everything by 8 here, 64 is equal to 15 squared plus 8c. 8c is then equal to 64 minus 15 squared. That feels wrong. Oh, it's minus 15, isn't it? Minus 15. So plus, it felt wrong because 15 squared is going to be larger than 64, and c wouldn't. C could be negative, sure. I mean, c wouldn't be negative as you can see from here, right? So that kind of stuff can always help you out. So then c is equal to 64 plus 15 squared by 8, which is 289 by 8, which is 36.125. So the equation of the circle then, it's not circle, tangent becomes y is equal to 15 over 8 plus x 36.125. There we go. That's the equation of the circle. Calculate the equation of the tangent. Line QR done. The tangent comes to the y-axis at r. Calculate the gradients of the point r. So again, we have the equation of the tangent being y is equal to 15 over 8x plus. It's easier to write this as a fraction as well because we have that first thing of fraction as well, 289. And then the tangent cuts to the y-axis at the point r, as you can see here. What's the y? So calculate the point. So basically the y-intercept, we say x is equal to 0, which implies y is equal to 289 by 8. So it says coordinates of r, right? So be specific and write 0, 289 by 8. And now calculate the area of the triangle OPR to 1 decimal point. So what's OPR? O to P to R. So we know this length, and we can probably find this length, and then base times height, and that does it. Or so since we know, so we know what OR is. This is 289 by 8. Sorry. We know what OP is. OP is what's it called? That was the radius, which was which is 17, right? Yeah, which was 17. That's 17. So we know what this is. The length is here, right? So we know PR, and it's actually worthwhile drawing this out again. So what is this? OPR. OPR. OR was 289 by 8. This is 17. So we know that PR squared is equal to 289 squared. 289 by 8 squared minus 17 squared. So PR is equal to. In fact, we can just leave it. We can say and then say therefore, and area is equal to. Both triangle is equal to half base times I. So half times 17 times PR. And now it's worthwhile. Now we want to find what PR is. So PR is 255 by 8. So half times 17 times by 255 by 8. And if we just do this on the calculator, it comes out to 270.9375. And if we round to one decimal place as it asks, 270. So if you round the 5, then the 9 becomes like a 1. There's 271.0 to 1 dp. There we go. And that's that. So this is I'd say a trickier one because it's multi-stage, and also this last part of calculating the triangle. But the steps aren't too big. If they were asked you, if you ignore all this and just went straight to calculate the area of the triangle OPR, you'd be like, oof, it's quite tricky. But they're kind of taking you through step by step, so it's not as tricky. But in general, just remember it's very formulaic, this kind of stuff. You find the equation of the circle, just you can remember what it looks like, and by that, it's like when you find the equation of the tangent, it's a very formulaic way to do it. They'll tell you the point. You find the gradient of this line, and you know the gradient of the tangent, and you know the point passes through. So bish bash bosh, you've got your equation of the tangent. Hopefully everything in this video made sense, and I'll see you guys in the next one.